Earth is unique in our solar system, a living, breathing planet with continents that drift, collide, and reshape themselves. But why does only our world have active plate tectonics? And how does this power the very life that thrives here, beneath our feet? The Earth is far from solid. Its crust floats atop a hot, convecting mantle, moving continents like puzzle pieces. Plate tectonics doesn't just build mountains or cause earthquakes, it regulates the planet, shapes climates, and even controls the carbon cycle that makes life possible. The ground we stand on isn't static. It's a dynamic system that has been in motion for billions of years, crafting the world we know today. This constant dance of geology is the secret behind Earth's enduring habitability, setting it apart from every other planet we've ever explored. The Earth's crust is broken into massive tectonic plates, all drifting atop the semi-fluid mantle below. What drives this incredible movement? It all starts with heat. Intense heat from radioactive decay deep within the Earth's core creates powerful convection currents in the mantle. Imagine a giant pot of boiling water, but instead of water, it's molten rock. And instead of a stove, it's the planet's own internal furnace. This slow, powerful churning pushes plates apart, pulls them together, and makes them scrape sideways against one another. Where plates collide, the crust buckles and folds, thrusting rocks skyward to form majestic mountain ranges like the Himalayas. Where they pull apart, vast rifts open up, creating new crust and forming entire oceans over millions of years. And where they grind past each other, immense pressure builds up and is suddenly released, shaking the land with powerful earthquakes. But this constant movement isn't just about destructive force, it's life-giving chemistry. Volcanic eruptions, a direct result of plate tectonics, release gases like carbon dioxide and water vapor into the atmosphere. This process acts like a planetary thermostat, recycling essential elements and stabilizing the climate over geological timescales. Without plate tectonics, Earth might have become a dead, stagnant rock, frozen like Mars or superheated like Venus. This planetary recycling system is the foundation for life itself. Plate tectonics shapes the continents, creating diverse environments from towering mountains to deep ocean trenches. It recycles essential materials from the Earth's interior to the surface, forming the fertile soils needed for agriculture. It carves out river valleys and ocean basins, controlling the flow of water across the globe. This ever-changing surface has driven evolution, forcing life to adapt and diversify. As continents drifted apart, species were isolated, leading to new evolutionary paths. Without this geological engine, the continents might have never separated, the oceans we know may never have formed, and the rich tapestry of complex life on Earth might never have existed. Our world is not just a stage for life. It is an active participant in its story. Modern science confirms this dynamic world with stunning precision. Using a network of satellites, GPS data allows us to track the movement of tectonic plates in real time. We can now measure that continents are drifting at a rate of a few centimeters per year, about the same speed your fingernails grow. Seismographs around the globe record the constant tremors and rumbles from deep within the Earth, mapping out fault lines and plate boundaries. We can watch live footage of volcanoes spewing molten rock, a direct and dramatic display of the planet's internal heat engine at work. All this data paints a clear picture. We live on a world that is constantly in motion, a living proof of the powerful processes that make Earth so unique in the cosmos. So, why Earth? Why is our planet the only one in the solar system with active plate tectonics? It comes down to a perfect combination of size, internal heat, and composition. Earth is large enough to have retained significant heat from its formation and from ongoing radioactive decay. This heat keeps the mantle partially molten and drives the convection currents necessary for plate movement. Planets like Mars are too small and have cooled down too much. Their geology now largely frozen and static. Venus, while similar in size, lacks the water needed to lubricate plate boundaries, causing its crust to be a single, solid shell. Earth hit the geological jackpot. Its dynamic nature is what keeps it alive, habitable, and ever-changing, a true cosmic rarity. Understanding plate tectonics is not just an academic exercise in geology. It's fundamental to understanding the engine of life. This process shapes our climates, fuels our oceans with nutrients, recycles the very air we breathe, and even helps us predict and prepare for natural disasters like earthquakes and volcanic eruptions. The active, churning crust beneath our feet is the reason our planet has been able to sustain life for billions of years, and it is the key to how it may continue to thrive long into the future. Earth isn't just a rock in space, it's a living system. But if plate tectonics is the hidden engine that drives life and shapes our world, what other unseen forces, deep beneath our feet, have yet to be discovered? In our next video, we'll explore Earth's magnetic field, the invisible shield that protects all life from deadly solar radiation, and what would happen if it suddenly disappeared. Thanks for watching. And don't forget to subscribe for more journeys into the science of our amazing world.